Hello, everyone. Welcome to the Mega Alumni Podcast. My name is Nehal, and I'm a PhD candidate in the MAE department at OSU. And as a part of our grad organization, Mega, we are doing this alumni podcast series to hopefully connect our current grad and undergrad students with the alums from our department, and just get a perspective on where life can go once you're done with your degree. And today we have a special guest. We have an alum from the department who is currently also the chair of the MA department, Dr. Rob Siston. So before we get into the conversation, Dr. Siston, would you like to just give a brief introduction about yourself?
Sure, happy to do that. And in terms of where you can go after you've graduated, I haven't gone very far. I'm in the same place I was 20 years ago, well, over 20 years ago now. So I'm originally resident of Strongsville, Ohio, up in Cleveland. So I graduated Strongsville High School in 1996. Having done that, grew up as a fan of the Cavs and the Browns, the Indians at the time. Now they're the Guardians. My senior year in high school was when the Browns left Cleveland into their last home season that fall of '95 before they went to Baltimore and became the Ravens. So I grew up with watching Michael Jordan torture the Cavs and all these other painful memories of the drive and the fumble for the Cleveland Browns. So I came to Ohio State in 1996 to then the Department of Mechanical Engineering. At the time, there was a separate Department of Aerospace Engineering, which is independent from the Department of Mechanical Engineering. And for what it's worth, there was a Department of Applied Mechanics as well. So the mechanics folks merged into the mechanical engineering department when I was a student here in the late 1990s. So I was a graduate, so I was an undergraduate here from 1996 to 2000. Instead of Scott Laboratory, there is an old Robinson Laboratory here at the same footprint as to where Scott Lab now sits. The sign of Robinson Laboratory is actually in a machine shop downstairs on the first floor here. So I graduated here from mechanical engineering in 2000. While I was here, along the way, I lived in Taylor Tower my freshman year, was a resident advisor in Lincoln House over by the river my sophomore and junior years. I lived in a house on Lane Avenue, East Lane Avenue, my senior year. Along the way of being a resident advisor, I met my wife in Lincoln House. She was actually a freshman on my floor when I was a resident advisor. And like any good RA, I convinced her to dump her boyfriend at the time because that boyfriend was no good for her. We've now been fast forwarding, we've now been married over 22 years. So that all sort of worked itself out there. Having graduated in 2000, I then went for Stanford University for my master's and PhD, receiving those in 2002 and 2005. I stuck around another year at Stanford for a postdoc, 2006, then came back here to Ohio State as an assistant professor back into the Department of Mechanical Engineering, summer, autumn of 2006. From there, rose up through the ranks of assistant professor, associate professor, and full professor, became interim department chair in August of 2021, and then non-interim permanent department chair in February of 2023.
All right. Thank you for giving us that introduction and yeah, going over the entire timeline of coming to OSU, leaving OSU, and then coming back to OSU. And you kind of briefly touched upon this a little bit already, but maybe you can give us some more details on just how different the undergrad curriculum and just the I don't know even how the graduate program was, considering aerospace and nuclear were all kind of separated at that point, and you were saying that even mechanics, there was a merger there as well. So, yeah, can you go over a little bit as to how different maybe your undergrad experience
Yeah.
at OSU was compared to how it is right now?
So the undergrad is a great place to start with that. So first of all, we were on the quarter system, not the semester system. We changed the semester system here at Ohio State in 2012. I believe it was. It was early. It wasn't that long ago, 12 or so years ago, 10, 12 years ago. So I went to school undergrad on the quarter system, went to grad school on the quarter system. And it's more of a sprint than is a marathon. It's a short 10-week bite of about four different courses, three, four different courses, and it moves at a blazingly fast speed. So one of the pluses of that is you get take more courses and more of a variety of courses. And if there's perhaps a little more flexibility in that curriculum, and if you frankly didn't like something, it was only 10 weeks, you could just pretty soon you'd go off and do something else. There were, I think, structurally a bunch of differences from that too. When I was an undergraduate, the capstone sequence here were two independent 10-week courses.
Hmm.
There is a paper-based design exercise, and there is a lab-based experimental piece on the mechanical side. I was part of a pilot project of a small group of us, about five of us, who did a year-long design build test of a robotic arm that attached to the side of a wheelchair. But only people in my group, that small group of us, were able to do this year-long project. Everyone else did 10 weeks here and 10 weeks there. But I think that's an example as well as the perhaps lack of hands-on emphasis
Hmm.
when I was an undergraduate. Now our undergraduates all do freshman engineering, whether that's freshman engineering honors with the robot or freshman engineering, all of which are highly experiential, hands-on project based. Back when I was a student, they were piloting something known as the Gateway program, which is the precursor to the freshman engineering honors program. Again, not all freshmen took it. I didn't take it, and I'm still kind of salty about that because of some bad advice I got at orientation in summer of '96. But it's almost 30 years ago, and I'm not holding a grudge at all for that. Um, so from the freshman year on, now we just have tremendous more hands-on opportunities here that are formally a part of the curriculum. 2900 on the mechanical engineering side, where half the class is in the machine shop and half the class is programming a microprocessor with an Arduino. Every one of our undergraduates takes that their sophomore year. We didn't have that sort of say practical applications here. So if you wanted to control a motor, for example, nowadays you're programming microprocessors, you're making cylinders for an air motor, you know how to do those sort of things. We theoretically knew how to model a motor and theoretically knew how to control it, but what's an H bridge and how to make wires with microprocessors and sensors and circuits and that sort of thing, we just weren't able to do that. So I think that's one of the things I'm most proud of as I've been here on faculty and we've evolved the undergraduate curriculum. It's much more hands-on and we're better combining the theory with the application. Because one of the things about engineering as a discipline is we are an artifacts-based discipline, particularly mechanical engineering and also electrical engineering. So we realize theory into practice. And unless you are practicing, realizing things into practice, it's really hard to translate your education into a career. So more hands-on laboratory experiences. We have many more students now involved with student project teams. While we had a couple of those when I was an undergraduate and I was helping with the first robotics team here when I was a student, it wasn't as common as it is now. So I think that's other than the quarter system, that's really one of the biggest differences is we're much more hands-on focused now than what we were. And talking to a bunch of the alumni that I do through my interactions as chair, they really see the difference in the students and the training that our students are receiving now compared to what they've seen, what they had experienced in their time.
Got it, got it. Yeah, so it seems like there have been a lot of changes over the years. I didn't do my undergrad here, but I've been a TA for a couple of courses, and I can also kind of attest to that. I've seen that there is a lot of emphasis on being really hands-on now, and getting a taste for what you're really going to do, especially with the different labs that we have in the department now.
Yeah.
Uh,
Well, let me to build off that too. The aerospace side, so the
mhm.
mechanical engineering curriculum has been very much hands-on based, perhaps more so than the aerospace side. So across the street in Bowles from where I am now. I'm in Scott now, across the street in Bowles. We're undergoing this major capital campaign to create a new educational lab for most of the aerospace undergraduate courses. And we have a very lofty goal of it, but it's really going to revolutionize the undergraduate curriculum and provide modern laboratory experiences to our aerospace engineering students. And doing we're fairly making very good progress on that campaign now. We're not quite halfway to our dollar amount, but we're going to add in ground-based robotics and aero-based robotics, so drone flying area, rocket test stands. We're going to put a telescope on a roof of one of the buildings around campus somewhere to track near Earth objects. So all these types of really, again, hands-on experiential type environments are going to hit both the mechanical and the aerospace side here.
Right. Yeah, that is quite interesting. And I'm wondering if there's anything similar happening with the nuclear side as well. I know it's a relatively smaller part of the department, I suppose, and I think it only has a specific uh it's only offered as a major for graduate level students, I believe, if I'm not
This is
wrong.
a tremendous question, actually. So you're right. Currently, we have only aerospace and mechanical undergraduate majors, and we have 3 graduate programs in mechanical aerospace and nuclear. Our nuclear minor is actually very popular. About 80, 90 some odd students are in the nuclear minor program. And when you look around to workforce needs in the state of Ohio and surrounding area, Indiana, Michigan, Kentucky, sort of that group, there's this big push for renewed focus in nuclear power in a variety of industries. So you might think traditionally like a nuclear power plant, but a lot of these new data centers for Amazon in the cloud and Microsoft cloud, or all these sorts of things, many of these new data centers are actually starting to turn to mini nuclear reactors on site to power the data centers. There's nuclear applications with naval submarines, like our current president has experience with in medicine, applications of nuclear engineering in medicine. So a lot of these jobs can really benefit from nuclear engineering. And we are currently now in the process of creating a nuclear engineering undergraduate major. Any one of these sorts of processes takes a fairly good bit of time, but it is our hope that it will be officially approved through all levels of the university sometime, if all goes well, in 2025, so that in the next couple of years we'll be able to be allowing freshmen who are new to the university to enroll in this nuclear undergraduate major. And I think that's going to be a tremendous addition to not only our department and the College of Engineering, but it's really going to be unique in the state of Ohio having that undergraduate major in nuclear.
Right. Okay, that sounds really interesting. And I've seen some of those headlines that you had mentioned as well, of a lot of the tech companies kind of really refocusing again because of the whole AI needing a lot of energy and running these big data centers. They are also like really investing into nuclear energy as
Yeah.
potential option to power that big data center. So I think it would be the timing seems really right for the nuclear major to come up in the
The
department.
timing is right, and it really is synergistic with a lot of other things doing in the department. So
Right.
there's applications of nuclear in space. So
Hmm.
nuclear thermal propulsion
Right.
for spacecraft, some of the settlements on supposedly on the moon or eventually on Mars that they're discussing most likely are going to be nuclear powered.
Hmm.
So it's not just nuclear. We are uniquely positioned as a department in an aerospace, mechanical
Right.
and aerospace department. So if you want to do nuclear in space, well, we have aerospace right here, all
Right.
under this roof. Applications of materials, for example, sensing, that sort of thing, mechanical and nuclear. So having all three under the same umbrella here really puts us as at an advantage.
Absolutely. Yeah. It really makes sense that the synergies between the three. majors that we have also is playing a big role in the department. Right. I guess the maybe going back a little bit to your time away from OSU while you were at Stanford. And I know you kind of mentioned that during your undergrad you had maybe one of the rarer opportunities of working on that year-long project and you were able to work on that robotic arm. I'm wondering what really took you to Stanford. I know that your lab right now here in the department is kind of focused on biomechanics in the broad area.
Yeah.
But I'm not sure if biomechanics was something you were interested in because of that project and you didn't have many opportunities in OSU at the time, and maybe that robotics control space was something you were seeking, you went to Stanford and then you were able to bring that back here. Um, yeah, what was that like?
Yeah, so that's a great question. So let me back up a bit for that. So growing up, at least my generation was shaped by the original Star Wars trilogy, and you can't convince me that Empire Strikes Back is not the best movie out of all nine. So when I was a kid and Empire Strikes Back was out and Return of the Jedi was the first movie I saw in the theater, actually. That's not here nor there. But Luke's robotic hand was one of the
Hmm.
coolest things that I remember seeing at the end of Empire Strikes Back when he's doing it with his hands and you see the chords doing that. It's like, that's fantastic. And growing up, I was always tinkering with things, building with things, and that sort of thing, and I always had Luke's sort of thing there. The cartoon Inspector Gadget I thought was always really interesting as well. So I always was of the mindset of building, creating, making things with this bio kind of focus, really kind of out there and kind of neat. When I was growing up, I had horrible knee problems. Osgood Slaughters when I was playing soccer for years, so much that I couldn't play for a while. In high school, I had horrible patellar tracking problems. So when I was running, my knees actually collapsed in together because I didn't have the strength to hold myself up when I was running. As I'm trying to run track and my knees are coming together, the coach is like, "You're okay?" I'm like, "I'm fine." They're like, "No, you're not fine. What are you doing? Your knees are
Right.
touching together. Go see the trainer," kind of thing. All of which really culminated when I was a car accident my senior year and I broke my hip. Later, I
Ah,
found out I tore my labrum as well. But as I broke my hip, I didn't need surgery, but I started to walk a little funny. And because I was
mm,
walking funny, um, eventually needed physical therapy because I was compensating too much by the pain and all this other sort of thing. So I remember my senior year in high school sitting under a heating pad on my couch thinking this is just terrible. I mean,
right.
I was broken leg. I'm sitting here, and after all these years of knee problems and whatnot, it's like, okay, my body's not working normally. And I was already kind of thinking this like an engineer. In addition, all along here is uh, I've had a speech impediment as far as I can remember, since I was born, as far as I can tell, as far as people tell me. But I remember in kindergarten having a speech impediment. So all the while I knew like this part of my body is not working. This whatever neural pathways are in my brain and my ears and that connection, that wasn't working normally. Now, orthopedically with my bones and joints, that wasn't working anyway. So I was like, okay. I remember sitting on this my couch thinking, okay, is there any sort of program where I can study how the body works because my
Mm,
body's not working normally?
mm,
Then maybe since I like building and creating things, there's a way to build stuff to help people
right.
whose body isn't working normally. And that's kind of where I left it in my senior year. And I was taking AP physics and AP computer science, all this other stuff. So I ended up coming here to Ohio State in mechanical engineering. I still remember my freshman survey class. They asked, well, what do you want to do and that sort of thing. And I sort of explained it to the instructor, and she said, well, here's this thing called biomechanics,
Mm,
which is a sort of a branch of mechanical engineering. I loosely heard of the term biomedical,
mm,
but I thought it was too cellular. I didn't kind of know. So as she explained it to me, I was like, okay, that's the thing
right.
that I want to do. So for the rest of my time here, I was looking for those sorts of experiences. And as it turned out, the former chair of the department here was building a galloping quadruped robot.
Hmm.
And he had
Okay.
previously built the six-legged walking machine that was massive. It was one of the really significant accomplishments of the 80s and 90s, this very large walker that was, I think, still somewhere on West Campus here at Ohio State. So his grad student, who is now a professor at Notre Dame and formerly here, he and I are still close. He was designing a leg for this galloping quadruped robot. So they had a project that they came up with to do the biomechanical analysis of a galloping dog.
Hmm.
Because if you study this dog, then maybe you can learn things about how animals gallop, and that can be applied to their robot. So one of the other grad students on this project, his name is Chris. He had a black Labrador named Molly. So I studied Molly running and galloping for my undergraduate thesis my senior year. We we my wife now, girlfriend at the time, sewed a dog swing. So we
Hmm.
put this dog in a swing and then swung her off of monkey bars in a park, which sounds like the most ridiculous thing to do. But if you can time the period of oscillation of a pendulum, you can calculate moments of inertia of a body. Plus, I did some solid modeling of the dog and I matched up galloping patterns of animals to this body, to the dog moving and that sort of thing. I had a ball, an absolute ball. So that combination of, okay, studying how people move,
Hmm.
or in this case, an animal, but
Right.
studying how people move, plus building the robotic arm was like, okay, I'm hooked. That's the kind of thing I want to do. At the time here, there's one faculty member doing biomechanics, and the name was Dept Burmy. And as it turns out, Dept Burmy founded the Burtech Corporation, which is one of the world's leader in force plates. So these are the plates you put into the ground or nowadays on treadmills or stairs that you record the force that you step down on the plate and the force that the ground pushes back on you. Nearly every motion capture laboratory in the country doing biomechanics has a force plate of some sort, with Burtech being one of the major players there. But he was sort of alone in doing that work. There wasn't a robust network of folks doing biomechanics here at Ohio State. And his focus wasn't really in line with my interests. So in looking around, I was looking at programs that had, one, a critical mass of folks doing biomechanics research, had a bunch of different courses that I could take, and then had applications where I could actually work with patients or study patients. And Stanford had and still does have a connection with the Veterans Affairs Palo Alto healthcare system.
Oh,
There's a fairly robust research lab at the VA Palo Alto that a lot of research on campus was being done there. Stanford has their own hospital there, and is really combination of good mechanical engineering courses plus uh, specific biomechanics courses, that it just had the combination, okay, folks that I could do research with, classes I could take, I think a variety of research avenues that I could follow. And that's what kind of drew me there to that environment. I'm happy to say now we've built up a fairly good collection of biomechanics folks here on campus in our department and some others here. So I do the neuromuscular and orthopedic biomechanics. We have folks doing cellular biomechanics, ocular biomechanics, bone biomechanics down the street, DNA origami, walking robots, all these other sorts of things. So now it might be a more difficult decision as to where to go, but at the time it was exactly the right move. I mean,
got it. Got it. Uh, can you go into a little more detail of what exactly your research work entailed while you were a grad student, and how you kind of moved or figured out your path to your kind of research as a professor from what you did during your grad school.
Right, exactly. So, in grad school, I was fortunate to be on a Whitaker Foundation Fellowship, which is a biomedical engineering foundation that no longer exists. Their goal was to spend out all the money. So I had great flexibility in what I could choose to do. And one of my classes was biomechanics of human movement.
Hmm.
Really fascinated about stuff I was learning. So I went up to the professor and it's like, hi, I'm on fellowship. I'm interested in this kind of stuff. What kind of products do you have? I'm interested in not only studying how people move, but I'm a design guy. I like building things. I like computer programming. So do you have computer programming where I could build stuff, work with people? And I kind of kept it that broad. I think one of the important things about grad school is being open to new ideas. So I knew I wanted bio, but I didn't go in there with I want to do this very specific thing. And if they didn't have this very specific thing, I didn't want to work with anybody. I knew generally what I wanted to do, and I wanted to learn more about stuff that was happening there. So he came back to me and was like, all right, I have this kind of side project that he was previously a faculty member at Northwestern, got his PhD at Stanford, left to go to a Northwestern, and then came back to Stanford. And he's like, it's called computer assisted surgery.
Okay.
Now, at the time, there were a bunch of companies that were developing these computer systems where you bring a optical tracking camera into an operating room to help surgeons make more accurate measurements and cuts of bones during surgery. So orthopedic surgery is largely carpentry. I'm good friends with a lot of orthopedic surgeons, so they're not going to be too mad at that for me. And a lot of the cuts are done by sight and by feel as to what, okay, sight in terms of using some mechanical guides at the time, but mostly how it looks to them. And then as you move the joints, this feels a little tight or feels a little loose. Now, doing things by feel and by sight isn't very satisfying for an engineer. So my advisor said, okay, we can build one of these systems and then we can sell it. Then we can make a lot of money and retire. Obviously, I didn't retire, nor did I make a lot of money. But we did build our system and working with some collaborators, not only at Stanford, but at the Robotics Institute at Carnegie Mellon, where I brought in a computer, the code I helped write with the folks at the Robotics Institute, and built some measurement tools to bring inside of the operating room at the VA Palo Alto of to help surgeons who are doing a total knee replacement surgery. So I built the system, I wrote the code, I created the algorithms, I tested it on cadavers and mechanical guides. And then my last year of my PhD and during some time of my postdoc there, we had this computer system inside of the operating room while the surgeon was operating on veterans undergoing a total knee replacement. And my system was compatible with or because they're not compatible, comparable with all the commercial systems that were going for, say, $250,000 or more with sold by major orthopedic companies. Now, their graphics were better and their UI was better. Functionally, it did the exact same thing. So seeing some of these industry reps look shocked when they came into the room, like, what's that? Our computer system is like, where do you get that? Hi. He's like, how do you do that? So it's very satisfying that I could engineer on par with what these orthopedic companies were doing, me and a good team around us, but also just to be literally 8 feet away from surgery in the room, having the surgeon use my tools during a surgery. It was like everything that I had wanted. I was designing parts, writing code, and we were making measurements on people and something that could directly benefit people. So your question then was, okay, how did that evolve? Because in general, it's never a good idea to compete with your advisor head to head, right? After you graduate, if you want to do the same stuff as your advisor, you're going to lose. You're just because you're behind, right? as it turns out, this was kind of a side gig for my advisor. He was always interested in it, but it wasn't his main thrust of his current research, nor was it his thrust of where he was going. So when I asked could I take it with me, he's like, yeah, fine, go ahead. He had no interest in really continuing it beyond a project that we were finishing up there that another student finished that I had started. So I was able to take most of that with me, excuse me, here to Ohio State. And then we were able to do like the next generation of that. One, we built more hardware and more tools to bring inside of the operating room here. But most of my advisor's focus was in dynamic simulations of human movement. So particularly during my postdoc year, I started to learn a little bit of how to do those computer simulations because like everyone else in my lab was doing these computer simulations for their PhD. Then there's me doing experimental orthopedic surgery work. So it's like every week is a different flavor of computer simulations of children with cerebral palsy. Then every fifth week or so, me with the total knee arthroplasty. And then more simulations than me with total knee. So I got into the simulation piece during my postdoc, and I brought that over with me as well. And that even wasn't competing with my advisor because he was researching a totally other pathology in cerebral palsy, applying this to modeling total knee components or how people rise from a chair or go up and down stairs after total knee replacement was totally different than what my advisor was doing as well. So I guess I was really fortunate that I could have a project I could bring almost in whole with me and also add some of the best pieces, parts of what other folks were doing as well. That was never in competition with my advisor. One reason I chose Ohio State was that it had a hospital system. Stanford does as well. And when I was finishing there, the VA drive was 10 minutes down the road. Traffic there's not great. 5-10 minutes down the road from where my office was at Stanford. But the main Stanford hospital was literally across the parking lot from the engineering building that I was sitting in. Here, Ohio State has multiple hospitals and centers where we do total knee replacement. Some on main campus, OSU East, but now up in Dublin, out in New Albany. We do a lot of around the city. There are other major, say, engineering programs that don't have a medical center associated with their university. There is a med school with a totally other university. And if there is a hospital, maybe there's some hospitals an hour or so away from main campus. So it's like nothing against like Purdue, for example, or Penn State. I have good friends at both and good collaborator of mine at Penn State, but there's no hospital on Penn State's main campus. If you want to work with surgeons, they're hours away at another place. So I couldn't do my work as well as a Penn State that I could do here, where I could now walk across campus to meet with orthopedic surgeons or sports medicine surgeons as my work has evolved here, or I live northwest of here. So the Dublin branch is on my way home. I just stop there on my way home, meet with a bunch of orthopedic surgeons, and then I drive home 10-15 minutes away from here. So that ability to have engineering and medicine on the same campus and closely working together really was a great opportunity for me to come back to Ohio State because I learned that value of that interdisciplinary work during my time at Stanford.
Got it. Got it. I guess the other question I have for also I'm also interested in academic positions after I graduate. So I was thinking if you also had any opportunity to teach while you were at Stanford or maybe TA for some courses. Did you get a feel for maybe any cultural differences in how things are taught, how students are perceiving school and education, and
Oh
something
my,
that you thought
oh my goodness. All
is
right.
different?
So I was able to volunteer TA for the biomechanics of movement course because my advisor was the one teaching it. I don't know how exactly HR legal that is, so let's not basically I got to do all the fun parts and things that I wanted to do because I was interested in teaching. So I got to
Hmm.
volunteer to do that, but I wasn't forced to do anything against like I could do office hours, so I was enjoying explaining stuff to people, but all the horrible questions I could hand off to the official TA of the class, like, "May, you can take this one. I don't really want to deal with that." So I had experience creating exam questions and learning how all that process went. And actually, it was during my postdoc year, part of the funding was a mechanism where my friend and I could co-teach that biomechanics of movement course. And we were both paid to do that there. And we learned how to teach and we developed new material for the class. And it was a really very positive experience to be the instructor of record during my training there, which is, I think, one of the reasons why I'm very proud of the FAST program that we have here is that there's you learn valuable things being a TA. You learn much more being an instructor of record when you are the person in charge of the course and you have to not only deliver the lectures, create their homeworks, create the exams, to match homeworks and balance and all of that stuff, but also all the grading and all the student emails and all the things. You really get a sense, okay, is this what I want to do or not, right? So us having that FAST program here, I think, is a great trading mechanism. Perhaps you have some opinions as to how that's going. But
I really like it. So I've already enrolled for both the courses. I'm done with that. I'm actually
yeah,
looking forward to teaching a course myself next semester.
there you go. Yeah,
Yeah, I'm looking forward to seeing how that goes. I'm hoping that it'll be good. I have had some TA experience, so I know I enjoy that student
yeah.
interaction, as you said. But yeah, a
Yeah.
lot of the I have had experience with some of the background logistics, but I would say like not all of it, which is what I'll experience next
Which is
semester.
exactly. So in terms of the differences, so at Stanford, at least when I was there, they have what's known as a shopping period. So you are allowed to enroll basically in as many courses as you want. Then I believe that was the end of the second week is when they lock the rosters. So you could sit on a couple of courses,
Hmm,
and if you didn't like it, you could just drop out.
right.
Um, at the now, okay, our undergraduate courses here range from 80 to 200 as to really the really big ones, with 140-ish to being our large typical size there. So when my friend and I were co-teaching this class, she's now a professor at North Carolina State. We were teaching this class in the fall. We looked at it, and at the roster, we had, I want to say close to 150 students enrolled. We're like, there ain't no way we're teaching is 120 or 150, but well north of 100 students. We're like, there ain't no way we're going to do this. And I remembered my second year of grad school, I had a professor who purposely made the first lecture ridiculously hard.
Hmm,
And
interesting.
there were like 20 people in this class, and he made it hard so that he said, okay, this is taught at Oxford and here, and probably nowhere else in the world. Is Sylvester's dialectic theorem or something to that effect. And it was ridiculous. The next class, we went from over 20 students to like 10. He looked
Wow.
around, like, okay, this is better. Then he started at the basics. So I said, okay, here's what we're going to do. First day, we're going to tank the first lecture. So we go to this class, and the room is all the seats are filled. People are sitting up and down the aisles around the room, staying at the back of the room like 2, 3 deep. So my friend and I teach, and I'm purposely trying to almost do as worst job as I can. And the TA came up to me afterwards, said, like, I just went through the GTA training as sponsored by the Teaching Learning Center, and you perfectly channeled what you're not supposed to do as an instructor. I'm like, well, that's good. Next class, we're down like to 70. I'm like, all right, here we go. So then we picked it up and we did that. So obviously we don't do that here at Ohio State, but I imagine it's a fairly common practice when you're trying to adjust enrollment uh, at Stanford. I will say that I was struck by, I mean, by being perfectly honest, some of the entitled nature of the students that I met
Hmm,
there. uh, compared to what's here. We challenge our students very much at this place, both grad and undergrad, as I'm sure you can attest to, right? And really, for the most part, our students work really hard and they're willing to work with you. I still remember this class that I was teaching. It had a final project and it had an oral presentation and it had a written report where we gave people feedback on the oral presentation that could then be used to inform the written report. So this group went and I said, okay, that's really great, but you need to talk about these two, three things in your written report because it's a fairly big gap. We gave you a little deduction in the oral, but really make sure it's in the written and everything we find. Well, they didn't do that
Hmm.
in the final report. And then this was in fall quarter, so I think they got an A minus overall. So then they came back to us in January, me and my friend who was teaching it, and they said, "You ruined our careers." I said, "To say who?" You ruined our careers, and I can no longer get into Duke Medical School
Hmm.
because of that A minus that you gave me.
Right.
And I taught this in fall of 2005. So it's the beginning of 2006, so almost 20 years ago. I remember the specificity of it for two reasons. One, it was Duke Medical School, not med school broadly, this
Right.
one school that they couldn't get into, and as to why they're thinking my one grade would affect their ability to get in that one school, I still haven't been explained to me. But it was the y'all, we told you what you needed to put in the report. You didn't do that, but somehow it's the instructor's fault here.
Right.
And there was a lot of that
Hmm.
sense of my wife worked on campus there at Stanford. It was a really fun experience for her. And she did a lot of student events with alumni and things. And so I was voluntold to chaperone a bunch of those. Some of the on-campus ones were fine, but they do like a big senior end of year party at like the baseball stadium where the San Francisco Giants played and other places downtown. And one time at the ballpark, students got out of the suites, ran down into the seats, ran out in the field, and obviously you're not supposed to be doing that. So we kind of, as chaperones, had to round them up. And the first answer was, "Do you know who my father is?" No, we don't know who your father is, nor do I care who your father is. I bet he would be concerned with you running around on the infield when you're not supposed to. So it was that difference of perhaps what students are entitled to versus what they were willing to work for is
Hmm.
something that struck me when I was teaching there that I still carry with me here as well. But that
Interesting.
opportunity to teach, I thought was an invaluable part of my training, though, before starting as an assistant professor.
Got it. Got it. Interesting. So now that you had all of these experiences and you were, I'm guessing, shopping for faculty positions across different universities, clearly you've mentioned a couple of reasons why you were coming back to OSU. But once you were back here, and now that you're department chair, you have gone over so many different milestones and stages. Uh, can you maybe talk a little bit more as to what it has been like to be a professor, undergo tenure, and then now being the department chair, kind of you're in a unique position that where you are even maybe taking on a lot of different responsibilities that very few professors in every department get to take on throughout their careers. So
As you're saying, I got through all these different milestones. You're saying I'm basically now old, is what you're telling me.
I did not say that.
You you you
I'm
you
just saying that
you.
you're extremely accomplished.
Yeah, I'm confident. My girls at home are the ones who tell me, "Dad, you're old. Why is your hair is gray, Dad? Why is that happening to you?" Um, I I will say that the tenure process was a stressful time. It's much better being on this side of it. But I think in some ways, I use that as motivation for my time as chair. So let me give you an example. That every department in the country, at least, should have documents about patterns of administration, which is what it sounds like, how the department runs, and then an appointments, promotion, and tenure document. The names might be different, but it's basically a document as to, okay, criteria for hiring people, criteria for being promoted to the different ranks, criteria for getting tenure, that sort of thing. What was frustrating to me and others at the time was that it was never really made clear what the goal was to achieve it. It was always more papers, more funding, more service, better teaching. It was more. And talking to some faculty now in my capacity as chair, they were frustrated that in their experiences, say the 1 year, they got really positive feedback. You're doing great. We love the publications, the funding, the number of students you're advising, whatever. The next year, they were told it's terrible. And they went to the chair and said, well, wait a minute. Last year, I was doing great. This year, I have more students and funding and whatever. I was doing more than I did last year, now worse than what so they felt like the goalposts were always being moved on them. And for me at the time, the interdisciplinary research was, I guess, difficult to put into context here. Because I was asked directly why I wasn't publishing in journals from the American Society of Mechanical Engineers. I said, well, my research is biomechanics. So I'm publishing in the best biomechanics journals and orthopedic research journals because that's where my research is. That's what my community is. And I was told, no, I need to publish in ASME journals. So I was in some ways being asked to fit what an ME faculty should look like. When there's one, nothing in the documentation that says that, and two, recognition of how the fields are evolving. So recognizing how stressful that time is, I try to talk with the assistant professors now and folks, our associate professors interested in going up for promotion. Let's look at what's written down, because this is what the faculty are going to be voting on by what this criteria is that's written down in the documentation. And let's put your work in this context. So I got, and at least here in MAE, the way tenure votes work and promotion votes work, all the department votes, all the eligible faculty of the department votes, and that's details that we can get into later if you want, on the candidate. And that counts as one vote. And the department chair has their own vote. I said, well, my vote is based on what's in the document. And the eligible faculty are instructed to vote what's in the document. And we've worked hard over the past couple of years with me as chair as making sure the faculty are knowing that you're voting on what's in the document and their record relative to what the written criteria are, not what you think the criteria should be, not if you think they're a nice person or they're not a nice person or whatever. It's what's written in the document in terms of scholarship, student advising, in-classroom teaching, internal service, external service, and all those sorts of things. So using that that stress as my time on going through the clock informed how I kind of wanted to do things here on this end as well. As a student here, I valued good in-classroom instruction as a student. I was fortunate enough to win a bunch of teaching awards as I was rising up through my time here. So developing things like the FAST program to teach people how to teach and give those people opportunities is something that's informed my time here as well. For a while, I led the undergraduate research program here in the department. I talked earlier, I did it as a student here, so I know there's value in that. So the fact that I did it, it was a great thrill for me to lead something that I took part of at a time as well. So I guess a lot of those things of experiences that I had that I thought were valuable or say that needed to be improved upon. So we mentioned that my capstone was sort of it's like pilot-based thing. Well, I got some NSF funding actually to create a class here for senior students to do a capstone to build assistive devices for persons with disabilities. So things like the robotic arm, I got funding to build it out as a class. Here, eventually partner with folks in biomedical engineering. They got NIH funding to continue that. And now it's their version of the capstone down the road at BME, and we're running a version of that here in MAE
Right.
that I was able to start during my time as an assistant professor based on experience I had as a student here. So I think it's satisfying to give back in many of those ways to things that I thought were strength and could be improved upon, and things like the uncertainty of the promotion and tenure process. If I'm able to provide some greater clarity and assurances of the process as chair, I think that's something valuable that I can do here.
Got it. Yeah, I would love to get into details on many of those things, but I see that we are running out of time. So I'm trying to like cherry pick maybe a few things that we can use to wrap up this episode. So I think the first thing that I had, and I think you touched upon this a little bit, but in a very broad sense, if you had any advice for young researchers right now who are maybe looking to figure out what their research kind of vision needs to be for their career to in a multidisciplinary kind of area where, as you said, there are some things that are maybe that are written that are based off of what research has been done, but then at the same time you're also looking forward a little bit, seeing where things can go, and where you can get funds from for what kind of work. Is there any advice that you would like to give to them as to how to uh, frame that vision for their careers?
So I'll frame this in one of two ways. As a younger, say, PhD student, graduate research student, I think I mentioned this earlier, be open to uh, ideas, possibilities, learning about new areas of research. Because if you're going to a place like Ohio State or MAE Stanford, or whatever, you have really smart faculty doing really cutting edge things that you've probably never heard about as an undergraduate. So really open yourself up to these new possibilities. And it seems uh, it was unbelievable advice that I got that I didn't believe at the time, but I do now, that really, like, your time now in grad school working on your PhD is really the only time where you can really lean into research.
Hmm.
Like when you become PI, then you're spending a lot of time writing grants and supervising others, whatever. But as a PhD student, particularly at the end, it's you and your research and the ability to let your mind try new approaches, ideas, ponder things, really read articles and kind of let those articles marinade, try new approaches, learn new techniques and skills or experiments, whatever. Really embrace that time here in school. But if you're considering a faculty career in particular, what I was always telling my PhD students, and they laugh at me because a lot of them are faculty now and find they're telling the same things to their students. One, by the time you leave, what are the tools that you want in your toolbox?
Hmm.
Are you going to be an experimentalist? Are you going to be computer simulation? Like, what are the things you can kind of hang your hat on? Okay, here's what I do. Because when you go up for tenure, what happens is your department will send out requests for letters of evaluation to experts in the field. It's about
Hmm.
5 to 10 people they want you to write letters. And they'll have to say, okay, what is your work and how does your work fit into the broader research community? And
Hmm.
what's the value of your work? So
Mhm.
what do you do and what's the quality of what you do? And that's what needs to be done at the year 6 of your time as assistant professor. But even like going in, okay, if you think about it that way, okay, what do I want to be known for?
Hmm.
So earlier in your time of your career as a PhD student, what can I learn? What are all the things that I'm going to be soaking up? But particularly if you're angling towards a faculty position, at the end of your PhD or after your postdoc time, okay, what am I going to be known for? Like in my
Hmm.
case, I was the guy who primarily was making measurements of total knee replacements inside of the operating room.
Hmm.
And then I extended that a little bit with computer simulations about total knee and then measurements of other knee surgeries. But it was knee biomechanics. I was that guy, mostly anchored in what I did on my PhD. So they thought of Rob Siston, they thought of that's what I did.
Right.
So how can you start to craft that identity?
Hmm.
Okay, this is as you're advancing through your PhD and thinking about going academia, what is it that you are going to be known for? You're the simulation guy, you're the experimental guy, you're the whatever it is, so that you can start intentionally building that career in terms of conferences you're attending, papers you're publishing, grants you're going after, to come up with a cohesive portfolio of projects
Right.
that are all related to one theme. So
Hmm.
that when you go up for tenure, you can say, okay, here's what my lab does around this theme. Maybe we have a couple of different approaches to that, but we are known for this.
Right.
And those tenure promotion cases I found go a lot easier
Hmm.
because the external reviewers can clearly point to what the person does, and the person can write very clearly, here's it is what I do. If someone is sort of scattered and does all these other sorts of unrelated topics, the letters come back that way as well. Like, I don't really know what this person like is based in and what their
Right.
found, foundational scholarship is in. So it's like at the beginning, you want to be very open to new ideas, but then as you go through a career, really focusing on the tools and the approach that make you you and how you want to cultivate that.
Got it. Got it. Yeah, I feel like yeah, that sounds like excellent advice. Thank you for sharing. The kind of wrap-up question that I usually ask is, and I think you covered out on this a little bit as well, is that if you had any specific advice for grad students who are starting out versus somebody who is in the middle of their program versus somebody who is ready to graduate, he or she is in their final semester. So if you had any specific advice that you haven't shared already.
So other than sort of the researchy piece that we touched upon here as well, one I offer two. One is get out of your lab.
Hmm.
No much as how your PI might want you in there all the time, you got to get out of the lab. So Mega, for example, has many fine opportunities and programs that you can do trivia nights, trips, and all other excursions, bagels, dinners, all this. Get out and do things. I sang in a choir during my time at grad school. We did a lot of intramural sports. I remember playing volleyball against Olympians
Mhm.
because Stanford has a bunch of Olympians, and these were people on the swim team at Stanford who are also Olympians. And we're a bunch of engineering grad students playing volleyball. I can tell you who won. You don't have to, right? But it was just you're out and you're doing things, right?
Right, right,
You need whatever that hobby is, but it needs to be a balance of the hobby
right.
that you're there for the work and the research and to learn. Don't like I had a buddy who spent so much time in all these other extracurricular activities, which is very easy to do. He was in grad school for years after I had left, just because he got so sucked into all the other things. So be involved in other things, but not at the detriment of while you're there. And above all, you got to take care of yourself.
Hmm.
Um, as you know, grad school in general is a very uncertain time. You go from like the rigidity of an undergrad program of what courses to take and what sequence, so flexibility in what classes to take, very open-endedness of research in general, and then research always doesn't go the way it's supposed to. You can go
Hmm.
weeks, if not months, with like nothing happening.
Right.
Everything you try fails, and you feel like you're not making any progress. And then I think every student I've had in my lab has contemplated opening a bakery because if they're no good in grad school, they can open a bakery and do that instead of engineering or whatever. And your mind can take you in a variety of places. So whether that's talking to your advisor, talking to folks like Nick and Megan here, or like in my case of grad school, I started actually seeing a therapist during my time in grad school because my mental health was not going in a very good place. And Ohio State has great resources here as well. And I think particularly in engineering, for worse, there's this attitude of I want it to be hard, and if it's
Hmm.
hard and hurts, that's fine. I'm just
Right.
going to kind of keep like powering through, and that's not the correct attitude. There, you want to be challenged, but you really need to take care of your mental, your physical, your spiritual health throughout your time here, because sacrificing your mental health or your physical health for a piece of paper is not worth it. So no matter where you are in that stage, be sure you're doing all the I say like they say that easy self-care things, like make sure you're
Right.
getting enough sleep, eating healthy foods, uh hanging out with friends that are supportive to you and uplifting, things like that. But if you are facing physical challenges, mental health challenges, do seek proper care for that. And there's I think it's the encouraging, it's something that people should be encouraged to do, and don't think you have to struggle through the uncertainty and to doubt by yourself. So I think if there's one message to end with is challenge yourself, but also take care of yourself.
Thank you very much. Yeah, that makes sense, and I think that is something that I've heard consistently from previous guests in some form or the other as well. So, thank you very much for joining us for this episode and sharing your experiences, your journey through grad school, undergrad, and then coming back to OSU. Um, for all the listeners, we will have links for all of our social media channels. Right in the description so you can find out more about what Mega is doing right there. Feel free to join us if you're interested in, getting out of your lab and doing different things. We're always looking for volunteers. Thank you very much again, Dr. Siston. If there's anything else that I did not ask and you wanted to share, or maybe just plug in for prospective students who are looking at OSU for and the MAE department, if there's anything you want to share as like the last sign off message, the floor is
No, I
yours.
think if you said you had other questions, and I could go on for days about why you want to come here as an undergrad or why you want to
Right.
come here as a grad student. If this podcast is well received, maybe I come back, and if it's not well received, then you'll never have to see me again. How about that?
I'm sure it'll be well received. So thank you very much for joining us and sharing your experiences.
All right, now, thank you.
Thank you.